CGLS.
CGLS copies.
CGLS NTD.
CGLS, go ahead.
Let's set the clock to resume at 1529er 19er.
152919, JLS copies. You have a pending resume set.
Thank you. SPE NTD.
Testing on 212.
The status of our one remaining constraint.
See, Steve, lots of detailed discussions over on 245, the build and rationale. I actually have the first copy of LCC waiver to ISO 1. The plan is to go ahead and verbalize that one last time over on 245, make sure we got everybody's concurrence for the rationale. And once we do that, I have already coordinated with CMTC. We will go ahead and defer that IPR real time over on 212, and we'll follow up with a program-approved waiver paperwork-wise later.
Okay, what's your estimate on time? Will we make it before end of hold?
Okay, we're coming out of the hold at 152919.
That's correct.
I would think we'd be able to finish it before the hold.
Yes, thank you. I'd like it as early as you can give it.
Okay, I know they're working it hard, and the waiver rationale is out to everybody now, so we'll just we're moving much closer to verbalizing that.
Thank you.
Welcome.
OTC, NTS.
OTC, CMPS, 212.
Yes.
Yeah, I'd like to give you a step 1100 complete.
NTD, CLHY, and CLOX, you all copy?
TD copies.
CLOX copy.
CLHY copy.
Houston flight NTD.
This is Houston flight.
You're going to require a sent data crew update today? OTC, CHD.
HCD.
Yeah, I can give you step 1125 at this time.
NTD Houston flight, there are no updates required.
Copy, no updates required.
Copy 1125.
And OTC and STM, step 1101 is not performed.
OTC copies. STM copies.
This is Shuttle Launch Control at T-minus 9 minutes and holding. About 25 minutes remain in this hold. Discussions are still underway in the Launch Control Center regarding ice that was found on the liquid hydrogen umbilical on its outboard side. Discussions have been continuing for the last several minutes, and the good news is that the ice appears to be dissipating or melting. And we'll let you know once a final determination has been made. During this 9-minute hold, several polls are normally taken to verify that the team is ready to proceed with launch. And we're pleased to be joined at this time by Glen Chen, who is the STS-120 payload manager. Good morning, Glenn.
Good morning, Mike.
This is an exciting day for you.
It is so, and we're looking forward to see Harmony go into orbit to join up with the International Space Station, and things are looking really good.
It is looking really good. Hopefully everything will converge this morning. We have a video that we've assembled and would like for you to talk to us about regarding the arrival of Harmony and getting her ready to go to flight.
Okay, sure.
We'll roll that video right now.
So we see the Super Transporter by Airbus coming in on the SLF landing site, and this is the what they call a Beluga aircraft. And Node 2 was shipped from Italy. As you know, it was built by Alenia Spazio, which is now Thales Alenia. And you see it being brought into the SSPF, where it was processed for the past 4 years, over 4 years. The Harmony module is going to be the home for the Japanese module Kibo, and also for the Columbus module, which is the next flight up. And here you see the technicians bringing it into the SSPF, lowering it into its test stand. It will be used to process for the next 4 years. In a bit here, we'll fast forward through the 4 years, and we'll see the Harmony module. Here it is now transported down the transfer aisle, getting ready to go to the canister for its trip to the pad to be integrated into the Discovery OV-103 orbiter. You can see the NASA and ESA logos on the module. Here's the canister going vertical. It's coming out of the canister rotation facility in the wee hours of September 27th when it went to the pad. And it took roughly a couple hours to get to the pad in the canister transport system. Here's a shot of the canister going up at the PCR level at the pad on the 27th of September. And the canister is hoisted to the PCR where we transfer the payload Harmony and using the PIGM system. And we use a PIGM, which is the payload ground handling mechanism, to insert it into the payload bay of the orbiter. And here's an overall shot where the canister is being hoisted very slowly and carefully to the PCR level. Here's a shot of the OPF High Bay 3, where we have the spare ORU orbital replacement unit for the main bus switching unit being inserted and installed into the payload bay of the orbiter on the starboard side. The technicians are gently lowering it and hoisting it. And here it is hard down, and they're doing the torquing of the payload into the bay. And here we have the TSA, which is basically a toolbox for the TRAD DTO. TRAD was basically the late add to the mission for the tile repair demonstration, and here's the toolbox being added to support that DTO, which is basically a detailed test objective. And here's a shot of the orbiter at the pad, and the Harmony vertically integrated into the payload bay of the orbiter. And here we are.
It's a beautiful sight.
There you go.
It will be even more beautiful in a few days once we're on orbit and Harmony is attached to Unity.
Indeed it will, and we're just anxious to see it go.
It's going to be an exciting flight. Lots of folks have been watching the process for quite a long time, as this Harmony module will open the door to international science from our European Space Agency and Japanese international partners.
Indeed it is, and we're very happy and very proud to see Harmony go, and very proud of the team that's worked for the past few years to get to where we are today.
Very good.
Okay, and thank you, Mike.
Thank you.
Okay.
Thank you, Glenn. Thanks for joining us.
Thank you.
NTD C-Prop 212. Red C-Prop.
Yes, sir. We've discussed this data that we were on Indian 2, the pressure and temperature shift that was concurrent with the 7 ppm increase in the recovery and the HAZ gas system. From an FCC standpoint, of course, we're way in on everything. Our limit right now is 150, and we're down in the neighborhood of 10 to 12. Talk about the engine project. They've seen the shift in the pressure and temperature before. They've never correlated it with H2 before, but the shift is small as it is. There's no real way we could do that with any accuracy or there's no previous history that we could fall back on along those lines. Being the shift as small as it is, they don't have a concern, so we don't consider this as an issue, and we're good with all the LCCs are go.
Copy, you're go in the current configuration.
That's the firm.
And STE NTD? STE NTD.
This is ST.
Had you heard CPROP's rationale for being go, and you concur?
Yes, I heard CPOP said, and I do concur. And John, can you give me the FD for the two FDs you guys were looking at for pressure and temperature?
Let's see the engine temp. You want to do it on 161 or?
Yeah, can we go over there and get that, please?
Okay.
You can CPROP.
This is Shuttle Launch Control. We're still in the T-minus 9-minute hold with about 18 minutes remaining in the hold. And we're happy to be joined at this time by Discovery Flow Director Stephanie Stilson. Good morning, Stephanie.
Good morning. Great to be here.
It's a wonderful day.
Beautiful day to launch.
We are, things look like they may be converging. We're less than 30 minutes away from our launch time at 11:38 a.m. Eastern Time. I know that you have a very exciting job, and Discovery is your ship, and this is a particularly proud day for you.
Absolutely.
I know that you worked with the television folks to put together a video, and we'd like to go ahead and play that now and have you discuss what's transpired.
That'd be great. Ready to go.
Okay, we'll roll the video.
At the end of July, external tank 120 arrived by barge from the Michoud Assembly Facility in Louisiana. The function of the tank is to provide propellants to the 3 Space Shuttle main engines. At the turn basin, we use the external tank transporter to move the tank out of the barge and over to the vehicle assembly building. Here you can see the aft attach point and propellant feed line of the aft of the tank. The other end is the nose cone, which has the liquid oxygen vent valve and fairing. The outside of the tank is covered in a polyurethane foam that protects it from extreme temperature variations. Although it looks like one big tank, it is actually made up of 2 tanks. The liquid oxygen tank is at the top, and the hydrogen tank is at the bottom. It takes us approximately 2 hours to move from the turn basin to the vehicle assembly building. The tank is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. Once the tank is located in the vehicle assembly building, we attach the sling and start the process of lifting the tank into the test and checkout cell. This is done using a 325-ton and 175-ton crane. The tank weighs over 58,000 pounds empty and takes approximately 12 hours to place the tank in the checkout cell. Once in the checkout cell, the tank is inspected and prepared for being mated to the solid rocket boosters. Prior to the arrival of the tank, the solid rocket booster segments are stacked on the mobile launch platform in the vehicle assembly building. The solid rocket boosters augment the thrust of the Space Shuttle main engines for the first 2 minutes of liftoff. Once stacking of the boosters is complete and the tank has been checked out, we begin the process of moving the tank from the test and checkout cell to the integration cell to be mated to the boosters. Running down the side of the tank, you can see the liquid oxygen feed line. You can also see the aft bipod connection points for the orbiter. The 325-ton crane lowers the tank down into position so that it can be bolted to the solid rocket boosters. We have technicians located on platforms around the boosters monitoring the lowering process to ensure the tank is in the exact position required. Here you can see the liquid oxygen feed line and the repress line and cable tray running down the side of the tank. While all of this is happening in the vehicle assembly building, the orbiter is being readied in the orbiter processing facility. The Space Shuttle main engines are removed and refurbished after every mission, and here we see them being reinstalled. Installing engines is a very slow and methodical process of making sure everything is lined up correctly as the engines are inserted into the aft compartment. Each engine is 14 feet long and 7.5 feet wide, providing 375,000 pounds of thrust during liftoff. When all the work in the mid-body of the orbiter is complete, we close the payload bay doors for rollover to the vehicle assembly building. Before closing the doors, we have to retract and stow the KU-band antenna. This is one of the antennas that allows the astronauts to communicate with the team in mission control while on orbit. The motors that drive the movement of the payload bay doors are designed to work in microgravity and are therefore not strong enough to close the doors under the pull of gravity here on Earth. So we have what we call a zero-gravity or zero-G system to assist the doors with closure. The yellow structure that you're seeing here is part of that zero-G system. Once all the test and checkout of the orbiter is complete, we are ready to roll the orbiter from the orbiter processing facility over to the vehicle assembly building so that it can be mated to the external tank. Similar to the tank transporter we saw earlier, the orbiter transporter has 76 wheels on 19 axles and can travel 12 miles per hour when it is not carrying an orbiter, but only 2 miles per hour if it is carrying an orbiter. The vehicle assembly building was originally built for the Apollo program in the 1960s and was later modified to accommodate the space shuttle. Coming into the vehicle assembly building, you can see the yellow sling in the background. The sling is attached and the 325 and 175 ton cranes lift the orbiter into the vertical position. It takes approximately 12 hours to lift the orbiter and get it into the mate position. The orbiter is 122 feet long with a 78-foot wingspan and weighs approximately 200,000 pounds. There are approximately 24,000 tile and over 3,000 thermal blankets on Discovery to protect the orbiter from the extreme temperature fluctuations seen on orbit and during re-entry. STS-120 will be the 120th space shuttle flight and Discovery's 35th flight. Once in the vertical position, we then begin the process of lifting the orbiter up and over the transom and into the integration cell. The vehicle assembly building is 525 feet tall, which is large enough to house the Statue of Liberty. In floor space, it covers 8 acres. Here you see the 3 space shuttle main engines. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. At the bottom of the picture, you see the external tank as the orbiter is lowered down to the mate position. Here are the engines coming into view with the red protective engine covers that will be removed before flight. Now you can see the trailing edge of the left-hand wing. The gray structures at the bottom of the screen are the tail service masts of the mobile launch platform that provide power, data, and fluid line connections to the orbiter. Once in place, the orbiter is bolted to the external tank at 3 attach points, and we are ready to roll the mobile launch platform with the complete shuttle stack out to the launch pad. The stack is moved by the crawler transporter. Instead of wheels, the crawler has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. The transporter is 131 feet long by 114 feet wide, which is comparable in size to the infield of a regulation baseball field. The crawler weighs 6 million pounds and uses 150 gallons of diesel fuel per mile as it travels down a gravel path out to the launch pad. At a speed of less than 1 mile per hour, it takes approximately 8 hours to travel just under 4 miles from the vehicle assembly building to the launch pad. Once at the launch pad, we spend about a month doing a full system checkout of the tank, boosters, and orbiter in preparation for today's launch.
Thank you very much, Stephanie.
Well, thank you. It was great.
That's a lot of work that has gotten us here today, and we're about 20 minutes away from hopefully a successful launch.
Well, the team has done a great job, and everyone's very excited, so hopefully we'll get off today.
Very good. Thank you. We'll let you get back to work. We're at T-minus 9 minutes in holding with approximately 10.5 minutes remaining in the hold.
OTC PLT, clear caution hardware, caution warning memory complete.
Copy.
Director.
Could you give us the update, latest on weather, sir? I understand we're going to be go.
Yes, sir. All is looking well.
And the vehicle is clean at this point.
Concur.
This is Shuttle Launch Control at T-minus 9 minutes and holding. About 8 minutes and 18 seconds remaining in the hold. The issue with ice forming on the liquid hydrogen umbilical outboard side has been cleared. The ice has diminished in size. It is dissipating. And additionally, analysis was conducted that determined that even at its original size, it would not have proven to be a concern for us today. At this point, all appears to be go for the launch of STS-120 at 11:38 a.m. Eastern Time. This is Shuttle Launch Control, T-minus 9 minutes and holding. About 6 minutes, 45 seconds remain in the hold. Space Shuttle Operations Manager Leroy Kane has pulled members of the mission management team, and they are ready to proceed with the count. NASA Test Director Steve Payne has completed his poll of various test conductors, including those responsible for the vehicle, the spacecraft, the range, the tracking stations, and all is looking good. Shuttle Weather Officer Kathy Winters has cleared us for launch from a launch perspective, and Houston Spaceflight Meteorology Group is also go for return to launch site and TAL weather.
So, JRPS and Houston Flight performed the L-15 recorder activation. ISL?
ISO copies and word.
RPS? JRPS. And Houston Flight.
Houston Flight copies, we'll put it in work.
MS1 OTC. OTC, MS1. Activate the V10 recorder. In work. OTC MS1, activate V10 recorder complete. Copy.
And attention on the net. This is ENTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC.
OTC, go.
TBC.
TBC is go.
TTC.
TTC is go.
LPS.
LPS is go.
Houston Flight.
Houston Flight is go.
MILA.
Milo's go.
STM.
STM is go.
Safety Console.
Safety console is go.
CSPE.
SP is go.
LRD.
LRD is go.
SRO.
SRO is go. You have a range clear to launch.
Copy. And CDR.
CDR is go.
Launch Director NTD.
Launch director.
Our launch team is ready to proceed.
Okay, copy that, Steve. Chief Processing Engineer, verify no constraints to launch.
Engineering team is go, Mike.
Thank you, Charlie. KSC Safety and Mission Assurance.
KSC Safety and Mission Assurance is go, Mike.
Copy, Mark. Payload Launch Manager.
Hey, Mike, on behalf of our partners at the European Space Agency and the Italian Space Agency, your NASA, Boeing, ISS teams go for launch.
Good. Thank you, Gennaro. Range weather.
We'll start in 3 minutes.
This is Shuttle Launch Control. About 2.5 minutes remaining in this 9-minute hold, or the hold at T-minus 9 minutes, and Launch Director Mike Leinbach has completed his poll. Confirmed with the Commander Pam Melroy, the crew is go, and everything is go for launch this morning.
The countdown clock will start in 2 minutes.
NTD ISL, recorder activation complete.
Copy, activation complete.
Ten minutes away from launch this morning of STS-120 at 11:38 and 19 seconds.
1 minute.
This is Shuttle Launch Control. We're just a few seconds away from resuming the countdown for the launch of Space Shuttle Discovery today.
3, 2, 1, mark.
And we're at T-minus 9 minutes and counting.
GLS auto sequence has been initiated.
The ground launch sequencer has been initiated. T-minus 8 minutes, 13 seconds and counting.
Connect the central buses to fuel cells per your checklist.
OTC, PLT, that didn't work.
Pilot George Zamka is now flipping switches in the cockpit to directly connect the 3 fuel cells to the essential power buses.
OTC, PLT, essential buses connected to fuel cells.
T-minus 7 minutes, 40 seconds and counting.
GLS's go for orbiter access arm rechecked.
And Discovery OTC, good luck getting ISS core complete and opening the gateway for all mankind in space.
Discovery copies.
Words to Pam Melroy from Orbiter Test Conductor John Craxon here in the Launch Control Center, and we see that the orbiter access arm is now being retracted away from the vehicle. This is the walkway used by the crew to gain entry into and out of Discovery, and it could be returned to position within seconds if it were necessary. All systems are go. Weather remains go. We're at T-minus 6 minutes, 30 seconds and counting.
OTC start APU display recorders.
Display recorders are running.
PLT, OTC, perform APU pre-start.
OTC, PLT, that's in work.
The orbiter test conductor has given pilot George Zamka the go-ahead to perform the auxiliary power unit pre-start procedure.
OTC, PLT, APU pre-start complete, 3 gray talkbacks.
Copy.
T-minus 5 minutes, 45 seconds and counting. All 3 APUs standing by for the start sequence. T-minus 5 minutes, 25 seconds and counting. T-minus 5 minutes and counting.
Go for orbiter APU start.
PLT, OTC, perform APU start.
OTC, PLT, that's in work.
CDR, OTC, reconfigure heaters.
We have a go for APU start, and the commander has been asked to turn off flash evaporator feed line heaters. T-minus 4 minutes, 40 seconds and counting. T-minus 4 minutes, 20 seconds and counting. The launch team has terminated liquid oxygen replenish to the external tank.
OTC, PLT, APU start complete, 3 heater reconfig complete.
3 good APUs, and the launch team is now initiating LOX drainback. A final purge sequence of the main engines will occur.
Purge sequence 4.
Go for purge sequence 4, T-minus 3 minutes, 53 seconds and counting. A final test of the flight control surfaces is now being conducted. This is a pre-programmed pattern of movements designed to verify the readiness for launch of the main engines and other flight control surfaces. T-minus 3 minutes, 30 seconds and counting. Final aero surface checks of the orbiter's wing, elevons, and rudder are completed. This verifies the orbiter's hydraulic systems are functioning properly. The 3 main engines are now being gimbaled as a final test before launch. T-minus 3 minutes and counting. Final pressurization of the external tank liquid oxygen tank is underway. And we're completing the gaseous nitrogen purge of the shuttle main engines.
PLT, OTC, clear caution and warning memory, verify no unexpected errors.
OTC, PLT, that's in work.
T-minus 2 minutes, 30 seconds and counting. The gaseous oxygen vent hood is slowly being retracted away from the top of the external tank. Pilot George Zamka has cleared the caution and warning memory system.
Discovery, OTC, close and lock your visors and initiate O2 flow.
Discovery copies. OTC, PLT, caution warning memory clear, no unexpected errors.
Copy.
T-minus 2 minutes and counting.
ELS is go for ET, LH2, pressurization.
Liquid hydrogen replenish of the external tank is now being terminated. All systems are go. T-minus 1 minute, 43 seconds and counting.
Minute 30 seconds.
One minute, 15 seconds and counting. The liquid hydrogen tank inside the external tank is reported to be at the proper flight pressure. T-minus 1 minute and counting. The ground launch sequencer will verify that the 3 main engines are ready to start. The SRB joint heaters are being deactivated at this time and power being removed from ground support equipment. T-minus 40 seconds. Transferring to orbiter internal power. Coming up on a go for Autosequence Start.
ELS is go for Autosequence Start.
And we have a go for Autosequence Start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T-minus 20 seconds. T-minus 16 seconds. Sound suppression water system has been activated, protecting Discovery and the launch pad from acoustical energy. We have a go for main engine start. T-minus 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery, hoisting harmony to the heavens and opening new gateways for international science. Discovery has cleared the tower.
Houston now controlling.
Roll program.
Roger, roll, Discovery.
Discovery's roll maneuver is complete. Is now in a heads down position on track for its flight to the International Space Station. Discovery 7 miles downrange at an altitude of 2 statute miles. Flying at 600 miles per hour. Discovery's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle. Now 50 seconds into the flight. Discovery 8 miles downrange from the Kennedy Space Center at an altitude of 6 statute miles, flying at 900 miles per hour.
Discovery Houston, go at throttle up.
Copy, go at throttle up.
The 3 engines on board are throttling back up. At liftoff, the fully fueled shuttle boosters and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. Discovery now 13 miles downrange at an altitude of 13 statute miles, flying at 1,700 miles per hour. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. Discovery now 24 miles downrange at an altitude 23 statute miles, flying at 2,700 miles per hour. 1 minute 58 seconds into the flight, standing by for burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter towards space. Booster officer here in Mission Control confirming the booster separation. Two minutes, 25 seconds into the flight. The propulsion officer here confirms that the orbital maneuvering system engines are firing, providing Discovery with an extra boost to orbit. Discovery now 58 miles downrange at an altitude of 40 statute miles, flying at 3,300 miles per hour.
Discovery Houston, 2-engine Maroon.
Copy, 2-engine Maroon.
Discovery can reach Maroon in the event of a single engine failure. However, all 3 main engines are still operating well. 3 minutes, 5 seconds into the flight, Discovery at an altitude of 47 statute miles, 85 miles downrange from the Kennedy Space Center, flying at 3,800 miles per hour. All continuing to go smoothly on Discovery's climb to orbit, on track for its link up with the International Space Station Thursday morning. Three minutes and 40 seconds into the flight, Discovery now 124 miles downrange at an altitude of 57 statute miles, flying at 4,600 miles per hour.
Discovery Houston, negative return.
Copy, negative return.
Discovery is now flying too high and too fast to return to the Kennedy Space Center and the shuttle landing facility in the event of an engine failure. However, all 3 main engines still continuing to function well. Discovery at an altitude of 62 statute miles, flying 172 miles downrange from the Kennedy Space Center at 5,400 miles per hour. The orbital maneuvering system engines are continuing to function well with about 4 minutes left in that extra boost for Discovery's climb to orbit. Now 4 minutes and 45 seconds into the flight, the Environmental Systems Officer confirms that the flash evaporator system has been activated to provide cooling before the payload bay doors are opened in orbit. And 5 minutes, 22 seconds in the flight, Discovery now 281 miles downrange from the Kennedy Space Center.
Discovery Houston, press to ATO, select Istrus.
Copy, press to ATO and we'll select Istrus.
Discovery can now reach a lower than planned.
Single engine ops 3.
Copy, single engine ops 3.
Discovery could now reach a lower than planned but a safe orbit on 2 engines should one fail, but all 3 continuing to perform well. The vehicle could also conduct a transatlantic abort landing on 1 engine should 2 fail at this point. Six minutes and 10 seconds into the flight, Discovery's engines have been commanded to swivel.
Single engine Istrus 104. Your shutdown plan is nominal. Your go for the plus X. Go for the pitch.
Copy all.
Discovery Houston, press to MECO.
Press to MECO.
Discovery is now in a heads-up position and can reach the planned orbit on 2 engines. All 3 engines continue to operate well. Now 6 minutes and 43 seconds into the flight. Discovery at an altitude of 66 miles, flying at 10,700 miles per hour.
Discovery Houston, single engine press 104.
Copy, single engine press 104.
7 minutes and 15 seconds into the flight, Discovery can reach its planned orbit on 1 engine should 2 fail. However, all 3 still performing well. The flow of fuel from the external tank into the 3 Space Shuttle main engines is equal to that of draining an average swimming pool in 25 seconds. Discovery's engines are now throttling back to maintain structural limits on the orbiter as it approaches loads near 3 times gravity.
Now 7 minutes, 57 seconds into the flight. Main engine cutoff confirmed, now 8 minutes and 35 seconds into flight. External tank separation is also confirmed. Nine minutes into the flight, Discovery and her crew now in orbit. Commander Pam Melroy, pilot George Zamka, flight engineer Stephanie Wilson, mission specialist Doug Wheelock.
Discovery Houston, that was a nominal MECO. OMS 1 is not required. We'll meet you in the post-OMS 1 tab.
Copy.
There's 4 crew members on the flight deck of Discovery. Down on the mid-deck, astronauts and mission specialist Scott Parazynski, Dan Tani, and Paolo Nespoli. Zamka, Wheelock, and Nespoli experiencing their first flight. Crew members on board Discovery will set up now for the handheld photography with the +X and pitch maneuver of Discovery to gather images of the external tank as it falls away. The crew members using a still camera and a mini digital video camera. This is Mission Control Houston, NASA television now originating from the Johnson Space Center. We see here in the Space Shuttle Flight Control Room where the ascent team of flight controllers is on console, just having monitored Discovery's climb to orbit and working through the final items in the ascent checklist and preparing to work through the post-insertion timeline to prepare Discovery for on-orbit operations. This view shows the consoles of the flight directors and Capcom, or spacecraft communicators. Overseeing operations here is Flight Director Norm Knight, the second from the top right corner. He's seated and joined by Flight Director Richard Jones, who oversaw the evaluation of the weather conditions for emergency landings at the Kennedy Space Center or transoceanic landing sites. Also seated at that console is Flight Director Brian Lunny, who will be overseeing the entry of Discovery at the conclusion of the mission. Astronaut Terry Burtz, the second from the lower left corner, is the Capcom, making the calls to the crew on board Discovery. Next to him is astronaut Lee Archambault, who served as the weather Capcom, communicating with Chief Astronaut Steve Lindsay, flying the shuttle training aircraft around at the Kennedy Space Center to evaluate the weather conditions.
Discovery Houston, your go for APU hide shutdown. Tail-only control is not required. Your preliminary TIG is 37:15.
Copy all, TIG 37:15.
And Discovery Houston, you can work the nominal procedures up to and including page 3-7.
Okay, we'll put that in work.
This is Mission Control Houston, the team here continuing to monitor activities on board the Space Shuttle Discovery as the crew sets up for the on-orbit operations for the mission. Standing by for the launch replays from the Kennedy Space Center, those expected momentarily. A post-launch news conference will also be held from the Kennedy Space Center, that expected at 12 p.m. Central Time, 1 p.m. Eastern.
Discovery Houston, you are 1 minute from spreading.
Copy, 1 minute from spreading.
Discovery Houston, your onboard TIG and targets are good, and you can press on through page 3-8.
Okay, copy. The onboard TIG and targets are good. We're going to load and press on.
Houston Discovery, preliminary mid-deck config, block 2 in work.
Houston copies, and thanks for the update. Discovery Houston, your targets look good. We're ready for the maneuver. We're 7 minutes from the burn.
Copy. We'll initiate the maneuver.
Houston Discovery, block 2 is complete. Pressing on to block 5 with WCS config activation.
Copy that, Scott. Thanks for the update.
Discovery, com check on handheld mic.
Got you loud and clear, George.
Copy, got you the same.
This is Mission Control Houston, continuing to watch the launch replays on NASA television as the crew on board the Space Shuttle Discovery now in orbit and working through procedures to set up for the rest of the mission. Clock's counting down here in the Space Shuttle Flight Control Room to the next main event, the use of the Orbital Maneuvering System engines for the A.M.E.T. burn that will more circularize Discovery's orbit. That a little less than 2 minutes from now. And the engines will burn for 2 minutes and 32 seconds at about 158 miles per hour, changing Discovery's orbit to set up for future maneuvers to guide Discovery towards the International Space Station, with the docking set just after 7:30 a.m. Central Time on Thursday. We're now 37 minutes and 30 seconds into Discovery's flight, and the orbital maneuvering system engines are burning, providing a change in Discovery's orbit to more circularize the path. The engines will burn for about 2.5 minutes.